Peel a banana. Feel that slight resistance as the skin splits. Smell that distinctive sweetness. Take a bite. The soft texture dissolves on your tongue, potassium flooding your system, joining the 4,000 other potassium atoms already in your blood. Now freeze. In the next 75 minutes, one of those potassium atoms in that bite will spontaneously create antimatter. Not in some distant laboratory. Inside you, a positron will appear from nothing, scream through your cells at nearly light speed, collide with an electron, and explode into pure energy. You just ate an antimatter factory. But here's what should really bother you. Richard Feynman once did a calculation about antimatter that made him lose sleep. Not because antimatter explodes. That's child's play. He lost sleep because antimatter's existence proves something about empty space itself that suggests reality could end. Not life, not Earth, reality, the laws of physics themselves. And the trigger could be anywhere. Could be that banana. Could be you. Stay with me, because nature is more absurd and wonderful than you've been told. You think you understand antimatter. Matter's evil twin. When they meet, pure annihilation. Energy released according to Einstein's famous equation. You've heard it cost billions to make a single gram. That we trap it in magnetic bottles. That it could theoretically fuel starships. Common sense is just a collection of prejudices we acquired by age 18, and this is one of them. The comfortable story we tell ourselves is that antimatter is exotic, distant, safely contained in particle accelerators. But your body contains about 140 milligrams of potassium, 40. Every second, some of those atoms decay. And when they do, they don't just release radiation, they birth antimatter into existence. Positrons, real, actual antimatter. Inside your lungs, your heart, your brain. This has been happening your entire life. Every banana, every potato, every glass of orange juice, they're all antimatter sources. We'll come back to why your breakfast matters more than you think. But I have to stop you before you get comfortable with that idea too. Because the real terror isn't that antimatter exists. It's what antimatter's existence reveals about the fabric of space itself. Where are you watching from? Drop your location in the comments. And if you've ever eaten a banana without knowing it was radioactive, hit subscribe, because this is about to get much stranger. Let me eliminate what you think you know. First wrong idea. Antimatter is rare. No. Cosmic rays create antimatter in Earth's atmosphere constantly, about a kilogram per year. Lightning bolts generate positrons. Hurricanes are antimatter factories. Hold on to that thought about natural antimatter production. It's going to matter in a way you don't expect. Second wrong idea. The danger is the explosion. When that positron from your banana hits an electron, yes, they annihilate. The mass converts to energy, 2 gamma rays shooting off in opposite directions. But the energy is tiny. You'd need to eat 10 million bananas simultaneously to match a firecracker. Third wrong idea. Antimatter is separate from matter, like oil and water. This is the deepest misconception. Antimatter isn't matter's opposite. It's matter's twin, born from the same quantum fields, obeying the same laws. Every particle can become its antiparticle. The electron in your phone screen right now could spontaneously flip into a positron if it had enough energy. But wait, I'm getting ahead of myself. Let's talk about what really scared Feynman. But here's where Feynman enters the story, and where things get genuinely troubling. In 1949, he was working on quantum electrodynamics when he noticed something in the mathematics that shouldn't be there. The equation suggested that antimatter wasn't just matter moving backward through time, though that's weird enough. The equation said something about empty space that made him question whether we should exist at all. Hold that thought about empty space. We'll need it soon. The calculation Feynman did was deceptively simple. But first, let me paint you a picture with something you can touch. Imagine a soap bubble floating in winter air. Looks stable, right? Perfect sphere, rainbow swirls, drifting peacefully. But the air around it is supersaturated with water vapor, ready to freeze. One tiny ice crystal touches that bubble, and instantly, the entire surface crystallizes. The bubble doesn't pop. It transforms into something else entirely, something with different properties, different rules. That bubble is our universe. Keep that image in your mind. We're going to need it when we talk about consciousness later. Now imagine a guitar string that's been tightened for years, holding its note. The metal seems solid, dependable, but inside, the bonds are under constant stress. One day, without warning, without being plucked, it snaps. Not from external force, but from internal tension finally winning. The energy was always there, waiting. Our vacuum is that string. Let's escalate. Picture a packed stadium, everyone sitting. One person stands. Maybe they saw something. Maybe they're stretching. Their neighbors notice and stand too. Then their neighbors. A wave of standing propagates through the crowd at a fixed speed, unstoppable once started. You can't unstand people who've already stood. That's how phase transitions work. Now the real analogy. Imagine a master recording tape holding the only copy of your favorite song. The magnetic particles encode the music perfectly, but those particles want to randomize. Given enough time, the tape demagnetizes. The music doesn't degrade, it vanishes, replaced by static. Except imagine if one spot of randomness could instantly rewrite the entire tape. Have you ever worried that reality itself might be that fragile? Tell us in the comments. Here's what Feynman calculated and why he lost sleep. Remember those quantum fields I mentioned? The existence of antimatter proves that the quantum vacuum, empty space, has structure. It's not nothing. It's a seething foam of virtual particles popping into existence and annihilating. But more terrifying, it has an energy level. And that level might not be the lowest possible. We might be living in what physicists call a false vacuum, like water that's liquid below freezing point, supercooled, needing just one crystal to trigger instant freezing. Remember that soap bubble analogy? This is where it becomes real. If our vacuum is false, then somewhere, anywhere, a quantum fluctuation could create a bubble of true vacuum. Lower energy, different laws of physics. That bubble would expand at the speed of light, converting our false vacuum to true vacuum. Not destroying matter, deleting the possibility of matter. Inside the bubble, particles couldn't form. Atoms couldn't exist. Chemistry becomes impossible. The wave of true vacuum would be invisible. You can't see it coming because light itself would be unmade at the boundary. One moment you exist. The next moment the concept of existence doesn't apply. Feynman calculated that if antimatter exists, which it does, then vacuum decay is mathematically possible. The universe is a pencil balanced on its point for 13.8 billion years. But anyway, here's the part that should give you hope. But wait, we're still here. Every second that passes without vacuum decay is data. Every banana you eat without triggering universal collapse is evidence. Remember when I said lightning creates antimatter? Every thunderstorm is a vacuum stability test. Think about what this means. The universe has existed for 13.8 billion years. That's about 4 times 10 to the 17 seconds. In every one of those seconds, in every cubic centimeter of space, quantum fluctuations could have triggered vacuum decay. They didn't. We're talking about 10 to the 120 possible triggering events that didn't trigger. Either we're impossibly lucky, lottery-winning lucky times a trillion, or something protects us. This is where the speculation gets wild but necessary. Maybe consciousness plays a role. Maybe observation, the act of measuring, of being aware, collapses not just quantum wave functions, but prevents vacuum collapse. We'll return to what this means for you personally in a moment. Every conscious observer is a stabilizing force. Your awareness, your ability to peel that banana and taste it, might be part of what holds reality together. Remember earlier when I said antimatter appears in your body? Each positron that forms is a tiny test of vacuum stability. Your body is constantly proving the universe is stable enough to exist. You're not just in the universe. You're part of its quality control. The DNA in your cells repairs itself 100,000 times per day, proofreading against errors. But the universe has no proofreading mechanism, unless consciousness is that mechanism. Unless we are that mechanism. Peeling back the layers of the onion, we find ourselves at the center. So where does this leave you? Holding your banana, knowing it's radioactive with antimatter? First, recognize what you are. You're a collection of atoms that spontaneously creates antimatter. You're a walking particle physics experiment. Your potassium, 40 heartbeat, is a cosmic metronome, marking time with positron emission. Every 75 minutes, boom, antimatter. Remember when we talked about that potassium flooding your system at the very beginning? Now you understand what that really means. But more than that, you're evidence that the universe prefers existence to non-existence. Tonight, I want you to try something specific. Lie down somewhere dark. Put your hand on your chest. Feel your heartbeat. That's potassium ions firing in your cardiac muscles. Some of those potassium atoms are radioactive. With each beat, you're proving the vacuum is stable. You're a 13.8 billion year success story. Your existence is the universe voting against vacuum decay, one heartbeat at a time. But also feel this. That warmth from your hand isn't just heat. It's infrared photons, electromagnetic radiation. You're glowing. Between the antimatter in your blood and the light from your skin, you're far stranger than you knew this morning. But I'm getting carried away. Let me bring this back to what it means for how you live. The universe isn't just vast and ancient and mysterious. It's fragile and persistent, and somehow includes you as a necessary component. If this shifted the way you see reality, share it with someone who needs their mind blown. Subscribe for more journeys into what physics really means for being human. And tell us in the comments what ordinary thing will never look the same to you now. Thanks for staying until the end with these jiggling atoms and unstable vacuums. Let's find things out together. Nature doesn't care about your intuition, but sometimes that's the most wonderful thing about it. The fact that you can sit there, eating antimatter, glowing with infrared light, your consciousness possibly helping to stabilize reality itself. This is what physics reveals when we peel back enough layers. You're not just an observer of the universe. You're an active participant in its continued existence. Every breath you take, every thought you think, every banana you peel, you're voting for reality to continue. And so far, reality is winning. The universe is absurd and wonderful, and so are you. Think about what happened today. You started by peeling a banana, the most ordinary act. You discovered you're eating antimatter. Then you learned that antimatter's existence implies the vacuum could decay, ending reality itself. But you also discovered that your continued existence, second by second, is evidence that something, maybe consciousness itself, stabilizes the universe. You went from breakfast to the fate of existence in 20 minutes. This is what physics does when we really follow it to its conclusions. It doesn't make the world less magical. It reveals that the magic was there all along, hiding in plain sight, in every ordinary moment. That banana peel you threw away, it's still radioactive, still producing antimatter. The potassium in your blood, still decaying, still testing vacuum stability with every positron. You haven't changed, but your understanding has transformed completely. You now know that you're not separate from the physics of the universe. You're an expression of it. Every atom in your body was forged in stars, scattered by supernovas, gathered by gravity, arranged by chemistry, and animated by consciousness into something that can contemplate its own existence. And that contemplation, that awareness, might be essential to the universe's stability. We are the universe understanding itself, and maybe, just maybe, that understanding is what keeps it all from collapsing. The calculations say vacuum decay is possible, but here we are, billions of years later, still existing. Either we're monumentally lucky, or consciousness and observation play a role we don't yet understand. Every scientist who measures a quantum state, every child who looks at the stars, every person feeling their heartbeat in the dark, we might all be threads in a fabric that holds reality together. Feynman lost sleep over his calculation because he saw both sides of it. The terrifying possibility that reality could end, and the profound mystery of why it hasn't. He understood that antimatter wasn't just about particle physics. It was about existence itself. The fact that we can create and study antimatter, that we can understand these risks and marvel at our continued existence. This is the real story. We're not just lucky to be here. We're part of why here continues to exist. Your body, with its antimatter-producing potassium, is a testament to the universe's preference for something over nothing. Every moment you exist is a vote cast against the void. And somehow, impossibly, beautifully, the vote keeps winning. Tomorrow morning, when you peel your next banana, you'll know what you're really doing. You're participating in a 13.8 billion year experiment in existence. You're consuming antimatter. You're glowing with infrared light. You're a conscious observer in a universe that might need conscious observers to survive. And you're proof that despite all the ways reality could end, vacuum decay, heat death, big rip, big crunch, it persists. It continues. It includes you. That's not just physics. That's poetry written in mathematics, performed by atoms, observed by consciousness, and somehow resulting in you. sitting there, changed by what you now know. The universe didn't have to include beings capable of understanding it, but it does. It includes you. And now you know that every banana is a reminder of how strange, fragile, and persistent reality is. You're not just a speck in the cosmos. You're a participant in its most fundamental processes. From the antimatter in your breakfast to the possibility of vacuum decay, from Feynman's sleepless nights to your beating heart, it's all connected.